It is undoubtedly the first celestial body to reach the interplanetary region outside our solar system. The motion is too fast, too erratic for the pull of the sun to keep up. It was the first thing we've seen that came from interstellar space, and its arrival caused a wave of excitement, speculation, and scientific research. Humans have been exploring space for decades, sending probes to the far reaches of the solar system and using telescopes to see things that the naked eye can't see. But when Oumuamua found out, everything changed. This mysterious visitor from space has been studied in recent years, and now the James Webb Space Telescope has revealed the first true image of this cosmic enigma, revealing details that no one else has ever seen. Come and join us as we dig. Look deeper into this image and see how the liberation of Oumuamua shook the foundations of our understanding of the world. Undoubtedly, Oumuamua is unique and fascinating. It rises from the depths of space, confirming its existence, and the whole world ends. Everyone wanted to learn more about it because it had never been discovered. This long, cigar-shaped visitor to our solar system came from a region of space beyond our own, an unusual interstellar probe that wanders the vastness of the universe to pay for a short trip. Its unique shape, like a thin cigar, what some call an infinite needle, is unlike anything we've seen before. The amazing discovery of Oumuamua was made on October 19, 2017, when the Pan-STARRS 1 telescope in Hawaii scanned the night sky and discovered the presence of this unusual object. It was a famous event, and it was the first time that astronomers had seen anything that came from outside our solar system. The amazing thing is that everything that reached our solar system went straight to Earth. The emergence of Oumuamua is one of the biggest astronomical events in recent memory, and it's important to dig deeper because it seems to hold the key to unlocking the mysteries of our great global environment. Confirmation of Oumuamua's interstellar origin was not a matter of haste, but of careful and thorough investigation. At first, the object was thought to be just an asteroid, one of the many types of space rocks that inhabit our solar system. But as astronomers gathered information, they realized that Oumuamua was nothing. Its orbit, speed, and unusual shape indicate that this solar system is not a native of our solar system, but a visitor from a distant star system thrown into space by a cosmic event and placed on the way to reach the sun. The system that approaches them. Our as the eyes of the world train their eyes on this mysterious visitor. It begins to take shape. Unlike any asteroids or comets we've seen, Oumuamua's elongated shape and slow motion defy conventional classification. It rotates like a bottle turning in the ocean, and its surface is more reflective than expected, suggesting a composition unlike any other in the solar system. A number of theories began to emerge. Was it a fragment of a planet that had been separated from its parent system by a catastrophic collision? A fragment of a comet that has been separated from its icy outer layers for years in the cold depths of the universe? Or is it something else, an alien artifact, an abandoned spacecraft drifting in space? These questions, though tempting, cannot be answered by looking at them. To be clear to Oumuamua, scientists need more data, and they need it fast. It's traveling at incredible speeds, faster than any spacecraft we've ever launched, and it's on a path that will soon take it out of our solar system forever. The surprise was revealed. He only had a few weeks to study this interstellar visitor before he disappeared into the darkness of the world, probably never to be seen again. Before this challenge, the astrologers gather around their resources. Astronomers from Hawaii to Chile and Spain all focused on Oumuamua, gathering as much data as possible before time ran out. The Pan-STARRS 1 telescope, which was the first to observe the position and speed of the object, while other observers provided additional data and recorded images and observations that helped solving the mystery of its origin. One of the most fascinating Oumuamua's characteristic is its brilliance. As it moves through space, its brightness changes dramatically, indicating that it appears to be very tall, longer than it is wide. This is in contrast to an asteroid or comet, which is round and irregular in shape. Changes in brightness indicate that the object is rotating, but not smoothly and uniformly. Instead, Oumuamua seems to be going around, pulling and turning in a random fashion. This type of motion is rare among celestial bodies, and it raised many questions about the forces acting on Oumuamua as it traveled through space. The color of the item is also a mystery. Oumuamua has a red appearance, similar to many asteroids in the solar system, but the surface is more reflective than expected. This indicates that a layer of material has been coated that is not only reflective, but also resistant to harsh environmental conditions. Some researchers suggest that the object is metal, perhaps the remains of a larger body that was destroyed by violence. Others suggest that Oumuamua may have been covered in carbon compounds resulting from chemical reactions as it traveled through the interstellar medium. As information continued to flow, scientists began to develop models to explain the origin and behavior of algae. One theory suggests that a fragment of a planet or moon has been ejected from its parent system by a close encounter with a larger object, such as a giant planet or black hole. This may explain its long appearance and speed, as well as its unusual rotational motion. Another theory suggests that Oumuamua is a fragment of a larger body that was torn apart by tidal waves while passing close to a star. In this case, Oumuamua is a type of celestial particle that is thrown into space by the gravitational pull of the star. Despite these amazing things, there are still many unanswered questions. For example, why does Oumuamua show no cometary gas impact even though it passes close to the sun? Most comets, when heated by the sun's rays, release plumes of gas and dust, creating a bright, glowing halo with a tail that stretches for millions of miles. But Oumuamua has shown no signs of such activity, despite passing within 25 cents of the sun, closer than Mercury's orbit. The lack of gas indicates that Oumuamua is not just a comet, but something else. The mystery deepens as scientists analyze the path of Oumuamua. As it moves away from the sun, its motion seems to deviate from what is expected based on the pull of the sun and the planets. The deviation is small but significant, indicating that an additional charge was applied to the object. One of the explanations is Oumuamua was under the pressure of the sun, a phenomenon known as the Yarkovsky effect. This effect occurs when the sun heats one side of an object and emits infrared radiation and produces a small but measurable force. However, for the Yarkovsky effect to explain the acceleration of Oumuamua, the material must be very light and thin, more like a sheet of paper than a solid rock. This led some scientists to propose a more exotic hypothesis, that Oumuamua might be an artificial object, perhaps a light sail designed by an advanced civilization. A light sail is a type of spacecraft that uses the pressure of sunlight to propel itself, and some researchers suggested that Oumuamua's elongated shape and unusual acceleration could be consistent with such a design. This idea was highly speculative, but it captured the imagination of the public and sparked a renewed interest in the search for extraterrestrial intelligence. As the debate over Oumuamua's true nature raged on, the James Webb Space Telescope, JWST, was poised to play a crucial role in the investigation. The JWST, with its powerful infrared capabilities, is ideally suited to study distant and faint objects, and its ability to detect heat signatures would provide valuable data on the composition and structure of Oumuamua. The extreme sensitivity and resolution of the telescope allows scientists to study Oumuamua in previously unseen detail and reveal information that was previously hidden. JWST's ability to collect and analyze infrared light is an important tool for studying interstellar objects like Oumuamua. Infrared light is less affected by dust and gas than visible light, allowing astronomers to see through the dark clouds surrounding celestial bodies. This makes JWST a valuable resource for exploring the outer regions of the solar system and beyond. Its advanced instruments can detect faint thermal signatures from objects that are too old, distant, or faint to be detected by other telescopes.